There is a long list of card games that is available on PC and mobile. There are even some that you can play in your web browser. From the classic solitaire to Uno to this. You can find anything you need. Well, except some local card games. Currently, the most local played cards variation are Rummy, President, Go Fish, and Setat. There might be more, but I don't remember the names. So we are going to make a card game. Okay, so first, let's set some very plain goals. First goal is that it needs to be 3D, because there is already many 2D cards game. Then it needs to be a multiplayer game, because nobody likes to play alone. It will also have a bot to play against, in case you have no friends. And finally, it should be targeted for PC and mobile platform. It should be pretty easy, right? Yeah, you have two paths for making games. Either you make everything from scratch, that is, you have no life, or you use a game engine. You still have no life, but it is easier. So we are going to choose the second option. Now we have to decide which game engine to use. Let's compare each. So we have Unity, Unreal Engine, Godot. All right, let me save up your time. I am pretty sure everyone knows the difference between Unity, Unreal, and Godot. So I chose Unity because I am a bit more familiar with it, despite its runtime fee controversy. And also because C++ is, not for me. Regarding the runtime fee, it's pretty straightforward to work around that. Just use an old version of Unity. Okay, so we got our game engine. It's time to begin. And we will set it to Unity Let's name it Card Game for now. Now that we have created the project, let's talk about cards. So you have the ace, the 2, the 3, the 4, the 5, the 6, the 7, the 9, the 10, the jack, the queen, and the king. So these 13 cards make up a suit, and we have 4 of them. There's the spade suit, heart suit, diamond suit, and the club suit. Now that we know what the card consists of, we can represent them in game. So for that, we will create an enum called card value. It will contain all the possible values for cards. Then we will also use an enum called card suit, containing the 4 possible suits. Also, an enum is basically a list of constants with designated names. Finally, we create a card struct. It contains the card value and the card suit, which will be used to identify the card. Now we need something to hold the cards, and that's what exactly the class, card deck, does. The class, card deck, uses a list instead of an array to hold the cards. I chose list because array has a fixed size, whereas with list, it automatically resizes to hold the new cards. Okay, so now we have cards and a way to hold them. We just need to shuffle them. To do that, I will be using the modern version of Fisher-Yates shuffle algorithm. So basically, let's say you have 5 cards. I select one random card from the range 0 to 3 and swap it with the last card. Then I select one random card from the range 0 to 2 and swap it with the card of index of 3. Then I select one random card from the range 0 to 1 and swap it with the card of index of 2. Finally, since there is only 2 cards left, we just swap them. So there you go, we have a shuffled deck. And here's the code for the algorithm. Now let's test if the shuffle works correctly. I have set up a simple scene with buttons to act as the cards, and created a small script that will update the button name to the card. So yes, it is working. Now we need some 3D model of the cards. And yeah, I ain't modeling for the first devlog. So let's search in the Unity marketplace. And yes, free asset. We ain't paying for a temporary asset. This seems pretty good to me. Now we need to install it in the Unity project. Now done, but we have a small issue. For some reason, the texture of the models are pink. And after searching videos on how to fix that, I finally got it. Now that we finally got the model to work, we need a way to load all the cards. So each one of the cards is named according to its value and suit. What we can do is search through the assets folder, sort them, and then finally load them. This approach is good because later it will be easier to change the card assets to a new one. So here's how I did it. We first search for all the card assets. The method findAssets searches in the folder that we specified and then returns an array of GUID of the cards. Each assets in the Unity project has an assigned GUID, and each one is unique. We then create an empty array of GameObject that have the same length of the amount of card assets found after searching. This GameObject array will contain the actual GameObject that will be loaded later. Then we convert the GUID to an actual path. The reason we need to convert it to a path is because the path contains the value and suit of the card. So, we loop through each of the GUIDs, use the method GUID to asset path to convert it to a path, and then update the array to hold the path. Now that every GUIDs is converted to a path, we sort them by using the method sortCardAssetPath. We will look into that method in a moment. Finally, we just loop through the sorted card path, uses the method loadAssetAtPath to load the card asset, and assigned it to the GameObject array, and return the GameObject array. Now let's see how the method sortCardAssetPath works. The method has two parameters. The first one, AssetPaths, which takes an array of card path. And the second parameter is an out parameter, which means it is a bit like a returning value. This parameter is an array of integer that will hold all the cards' final value. This means if the first element in the sorted card path array is the path of the card 3 heart, the first element in the corresponding path card value array will have the final value of the card 3 heart. So we first created an empty integer array that will hold the card's final value with same length of the amount of card path provided. Then we loop through each card path. Okay, so the first step is to get the important detail of the path. That is only a part of the name. So we remove the directories that the path contain, leaving only the name left. Then we remove the prefix of the name, leaving only the card value and suit. The second step is to check if the card value and suit left are valid. We will do this by using regex expression. Don't ask how regex works, it just works. So we first check for the card value, and if it is valid, we update the variable card value. Then we check for the card suit, and if it is valid, we update the variable card suit. Finally, we calculate the final card value and set it to the corresponding path card value array. So let's see how we calculate the final card value. So remember that enums are basically just constants with name, and we are using two enums to represent a card, the card value enum and card suit enum. Let's say that you have a card of 3 heart, and to get its final value, you just take the value for 3 and the value for heart and add them together. There you have it. The number 16 is the final value of the card 3 heart. Here in the code, you can see that I was multiplying them, but later I changed it to summing the two values. Finally, since we have the final value of the cards, we can just sort them ascendingly, and while swapping the final value of cards, we swap the card path at the same time. Then we just update the corresponding path card value and return the sorted asset paths. So here we have it. We can now sort and load cards. To finish it, I watched a tutorial on how to make custom inspector so that I can spawn the cards using the inspector. So, let's try to spawn a card. So now we can spawn cards. Finally, it's now 2024. So let's get going. The next step is input detection. The first thing we need is mouse input, and it's pretty simple. We first get the mouse position in screen space. With this screen space mouse position, we can get the mouse actual position and pointing direction in world space using the method screenPointToRay. So now we have the mouse position in world space and its pointing direction. We can cast a ray to check where the mouse is pointing to in world space. Also, when casting ray to check if it's pointing to card, you need to make sure the card game object has a box collider. It took me hours to find that. Finally, we can check if we right-clicked while pointing to a card, then we will play the card, or if we left-clicked while pointing to a card, then we will hold the card. As you just saw, I wanted the cards to circle the player. In order to do that, I made use of Bezier curve. Unity does not have a tool for Bezier curve, so I had to make one. I watched Sebastian Legge curve editor series to make a custom Bezier curve editor in Unity. Also, to anyone interested, he did release a path editor tool for Unity. I just did not know about it at that time. So the tutorial was in 2D, and my game is in 3D, so I had to adapt it to 3D, but in the end, it did end up working. I also did some modification on how the Bezier curve works. Originally, if you move or rotate the game object, the Bezier would remain still. But now, with my version, the Bezier curve move with and rotate along with the game object. So the Bezier curve is done. Now we need to make a circle using Bezier curve. Luckily, I found a resource that explained how to approximate a circle using Bezier curve. The link will be in description. So, let's spawn some cards using the circular Bezier curve and see how it is. Okay, let me explain how and what kind of card variation we will add for the first devlog. We are going to add a local variation of rummy. So, to play the rummy, you need at least 2-person, which includes you, and up to 4-person with a deck of cards. You will start with 10 cards in your hand. And when it is your turn, you will draw 1 card from the table. And then you choose any card from your hand and place it on the table. Then your turn ends. That means after each turn, you should be left with 10 cards in your hand. Now we have 2 things called the sequence and the set. You are considered to have a valid sequence when you have at least 3 cards with consecutive values and with same suit. You are not limited to just 3 cards. Your entire hand can be filled with just a valid sequence. Now a valid set is when you have at least 3 cards with same value but different suit. You can have a max of 4 cards in a valid set, as only 4 different suits exist. So, in order to win, your hand needs to contain sequences and sets in such a way that no card is left out with no use. Also, to be able to win, you need to have at least 1 sequence. Even though you have a handful of sets, you need to make a valid sequence play to be able to win. Finally, to end this explanation, each time a game of rummy starts, a random card is selected as the wild card. This implies that any card having the same value as the wild card can replace any cards according to your desire. So now let's make the bot. To make the bot, we first need to detect if a hand of cards can win. And to do that, it's pretty simple. We first make a function to check for valid sequence and another function for valid set. Then we create out a function called CanPlayerWins, and in it, we pass the list of cards to check for sequence play and check for set play. Each time the functions found valid plays, we remove them from the list and pass them again. So finally, if the list is empty, the player has won. Otherwise, nope. For example, when we pass this list of card to CanPlayerWins, it will be passed to check for sequence play. Since there is a sequence of 3 heart, 4 heart, and 5 heart, these cards will be removed from the list, and the list will be sent back to CanPlayerWins. Then, CanPlayerWins will pass the new updated list to check for set play. Since there is a set of 7, these cards will be removed, and then the empty list will be sent back to CanPlayerWins. When CanPlayerWins receive the empty list, it will tell the game that the player won. Well, you know, this seems pretty easy when explaining, but yeah, actually coding it is hell. So let's make the bot now. Basically, we need a way to make plays, both sequence and set, and we need to find the most useless card to remove it from the bot deck. So to make plays, we are going to make 2 copies of the list of cards. The first one, we sorted as we did for loading cards. Since it is sorted by their final value, we have sorted the cards for checking sequence play. Then for the second one, we sort it only by its value. That is the number or alphabet in the card. With this type of sorting, we have sorted the cards for checking set play. Now we keep the valid sequence play and valid set play and remove the rest. Now we just join the 2 valid plays together and add the missing card from the original list. Finally, we can remove the 10 heart to end the bot's turn, as it does not belong in any play. This was an example with 7 cards, but when actually playing it will be with 11 cards, and 1 card will be removed, making it 10 after the bot's turn ended. So here you go, we have a rummy bot. In reality, the rummy bot is much more complex, as there are so many different conditions. You need to check if you are using the same card. You need to select the most useless card. You need to set the valid card combination that is uses the most. You need to join the sequence play and set one more. You need to make the best play. The rummy bot does all that, but it is not perfect though. There are still improvements that I need to do. So let's play some match against the bot. So we have 3 7s, we can make a set out of it. We don't really have other plays that we can create. So we can just sort the card a bit. Look, we have 4 spade and 5 spade. If we get a 3 spade or a 6 spade, we could have a sequence play. I don't see any play that the ace spade can be fit into, so let's remove it. So the bot threw a 7 spade, and that's exactly what we need. Let's just place it near the other spades, and then we remove the 5 diamond. Six heart. Let's replace out heart jack with the 6 heart that the bot dropped. So 10 spade. What we can do is, we take it for the spade sequence, and then remove the 8 heart. We don't need the queen heart, so let's draw from the table deck. Yeah, we don't need that. 3 spade. So the spade sequence is growing. Let's just sort it, and then we remove the 6 heart. We don't need that. It's not worth breaking our plays for that. This too. Six spade, perfect. Let's just reorder them, then remove the jack spade as we are missing a 9 spade. Nope, does not need that. 9 spade. That was missing. So look, we have a set of 7 and a sequence of spade from 3 to 10. We just need to throw the 10 and then we win. Let's see what was missing that prevented the bot from winning. So we have a club sequence from 9 to king and a diamond sequence from jack to ace, which made use of the wild card too. Only the last ace club prevented him from winning. Well, if the ace club would be right after the king club, the bot would have won. Well, that is a bug to fix. That was not the only bug. For nearly everything, something had to be broken or just would not work. But in the end, I did manage to make them barely work.